Hey guys, today we're looking at our last section in chapter 7, 7.4, which is all about solving rational equations, but here we're doing part 2. So this is option number 2 for us on how we can solve a rational equation. So when a rational equation isn't a proportion, which means just a fraction equal to a fraction, where we cross multiplied like we did in the first part of 7.4, we can also solve by multiplying by the LCD. So you remember our second option for 7.3 when we had complex numbers. Our second option was to take and find our LCD of the entire complex fraction and multiply our entire fraction by that LCD. Fraction busting is kind of the same thing, which is what I call what we're doing here today. We're going to start by finding all of my denominators and factoring them out, figuring out what those factors are of those polynomials, and then include that in my LCD. And then I take my equation and multiply everything in that equation by that LCD. So just as a quick little recap for us, if we wanted to try and find the LCD of 9x squared and 3x squared plus 3x, we would start by factoring out, which 9x squared is already factored out as far as it can. In my second denominator, so my second expression here, 3x squared plus 3x has a 3x in common. That leaves me with x plus 1. X plus 1. So my LCD has to include all of my factors from my expressions. So from my numbers, 3 and 9, the LCD would be 9. 9 is the smallest number that they both go into. For my x's, I have x to the first and x squared, which means x squared is that smallest number that it goes into. And then last but not least, my x plus 1, which is my only expression, my only parenthesis term, has to also be in my answer as well. So if those are my two denominators, I would multiply my entire equation by that LCD. What's in common will cancel, and I'm left with just a regular old equation that I can solve. So hopping over here into box 2, actually using one of those. So my LCD of this entire equation, I have x, I have 4, and I have x. So nice and easy to start us off with here. 4x is that LCD. So I'm going to take and multiply both, or I guess in this case, all three of my equations by 4x, because that's my LCD. That's my common denominator. That's going to make everything cancel out. So in all three of these terms, get multiplied by 4x times 4x. And then just like we did with complex fractions, we're just going to cancel out whatever's in common. So in this first fraction, my x's are in common, so they cancel, leave me with 4 times 5, which is 20, plus, in my middle fraction, my 4's cancel, which leaves me with the 7 and the x, equals. And then last but not least, my x's cancel out. Negative 36 is what we get when we multiply negative 9 times 4. So all of my fractions have now been busted. They're gone. They've been eliminated. And I'm just left with 20 plus 7x equals negative 36. So I can just go ahead and solve that pre-algebra, middle school math equation and solve that for x. So subtract 20 on both sides gives me 7x equals negative 56. And of course I divide by 7 on both sides, and we end up with negative 8. Negative 8 is my solution. So that is an easy version of fraction busting. If we take a look at a more complicated version in box 3 has 1 minus 8 over x minus 5 equals 3 over x. So my LCD, we'll start there. My LCD should be x times x minus 5. Those are the only things that happen in my denominators, so those are my LCDs, or that is my LCD. So I have to multiply everything in my equation by that LCD. Even though this first one is not a fraction, it still gets multiplied times by x times x minus 5. So x times x minus 5, x times x minus 5, x times x minus 5, And once again, we cancel what's in common. In my first term, nothing cancels because it doesn't have a denominator. So I'm just left with x minus x, or x times x minus 5, which I'm going to go ahead and distribute x squared minus 5x. In my middle fraction, my x minus 5's cancel, leave me with just x and 8, so minus 8x. And on my right side, my x's cancel. 3 times x minus 5 leaves me with 3x minus 15. So I've got a quadratic I have to solve, but at least it's just single level. My fractions are gone. I can just solve however I need to. So, of course, since we're solving a quadratic, we want to try and move it all over on one side and then factor. So that's what I'm going to do. I'm going to subtract my 3x and add my 15. So I've got 0 on the right. Collecting up all my, add 15. Collecting up all my like terms on the left side, x squared is still just x squared. Negative 5, negative 8, and negative 3 adds up to a total of negative 16x. And then my 15 is still just 15. So from here, I can go ahead and factor. That is just a regular old school two-parenthesis factoring method. I'm trying to figure out what multiplies together to give me a positive 15, but adds up to a negative 16. And as we've seen, the only way that that's possible is if they're both negative. And in this case, specifically, it's negative 15 and negative 1 that multiply together to give me 15, but add up to negative 16. So if I set each of those denominators equal to 0, or not denominators, each of these factors equal to 0, we get negative, no, yeah, that was right, 15, I don't know why I can't write today, there we go, and positive 1. Right, because all I'm doing is setting each of those equal to 0 and then solve. So x minus 15 equals 0, I add 15, x minus 1 equals 0, I add 1. So those are my two solutions. Now, just like always, we should be going back to check to make sure that our solutions don't give me a 0 in the denominator, just like we saw yesterday, or I guess the previous day in part 1. If we go back and check our answer and it gives us a 0 in the denominator, we can't include that in my answer. It's an extraneous solution. Which here, 15 and 1 are both fine. They don't give me a 0 in my denominator, but as the next title gives away with box 4, we are going to have one in this last problem. So, for this last one, in number 4, I have to start by factoring out everything that I can. This is the first one I've had to factor. X squared minus 9 is x plus 3, x minus 3, which we can see those are the only two factors that show up in my equations at all. So my LCD for this problem are just those two parentheses, x plus 3, x minus 3. So each of my 3 fractions have to get multiplied by both of those two parentheses. So x plus 3, x minus 3, x plus 3, x minus 3. It's getting kind of messy and running out of room. Maybe I'll skinny up my markers here just for this first part. X plus 3, x minus 3. This is times x plus 3, x minus 3, x plus 3, x minus 3. And now I can go back to my thick boy and cancel out what's in common. So in this first fraction, my x minus 3's cancel out, leave me with x times x plus 3. So that gives me 6x plus 18. Here in my middle one, x plus 3's cancel, x minus 3's cancel, so basically everything cancels. Leave me with just what was my numerator, x squared, 8x squared. And then over here, my x plus 3's cancel out, leave me with 4x times x minus 3. So minus 4x squared. And this actually becomes a plus 12x. Because of this negative sign that was here, this is really like a negative 4 times x, which is negative 4x squared, and a negative 4 times negative 3, which is a positive 12x. And once again from here, I can collect my like terms and get everything over on one side. So I'm going to have to move my 6x over here, subtract my 18 over here. That gives me 0 equals 4x squared plus 6x minus 18. So, first things first, to solve it, I'm going to go ahead and just divide through by my GCF. All three of those are even numbers. So I'm technically dividing all the way through by 2, which gives me 0 equals 2x squared plus 3x minus 9. And that's what I'm going to try and factor out. So I can do that a couple of different ways. It's got a leading coefficient of 2, though, so just guessing and checking at old school two-parenthesis factoring, probably not the best idea. So unfortunately here, we're going to have to go to Xbox factoring. So remember, for Xbox factoring, in our X, it's always our first term times our last term. So 2x squared times negative 9 is negative 18x squared. And then my middle term here is 3x. So I'm trying to figure out what two things multiply together to give me a negative 18, but add up to a positive 3, which 6x and negative 3x would be those two things, right? Because 6 times negative 3 is negative 18. 6 plus negative 3 is a positive 3. So then my box, there we go, that's lovely. Inside the box is always first term in your top left corner, last term in your bottom right corner, and then the two things that we just figured out, 6x and negative 3x, are those last two pieces. So remember, for Xbox factoring, I'm just looking for GCFs. So this top row, 2x squared and 6x, have a 2x in common. Right, they're both even and they both have an x value. And once you have that first one, you kind of just bounce around and find the other pieces. If 2x times x gives me 2x squared, 2x times 3 gives me 6x, and then either x times negative 3 gives me negative 3x, or 3 times negative 3 gives me negative 9. This factors out into 0 equals 2x minus 3 times x plus 3. So when I go to solve, 2x minus 3 equals 0, and x plus 3 equals 0. So 2x equals 3, x equals negative 3 there. So x is 3 over 2, or 1.5. So, again, what I have to check and be careful of before I box my answers in, I have to see if either of those solutions are going to give me a 0 in my denominator, which negative 3 is going to be an issue, because negative 3 plugged in either here or here are both going to give me 0 as that denominator, because negative 3 squared is 9, 9 minus 9 is 0, or negative 3 plus 3 is 0, which is going to give me a 0 for that denominator. So in this case, negative 3 is not a solution, because again, I'll just do one direction there. This is once again extraneous. So that tells me that just 1.5, or 3 over 2, is my solution. Alrighty. So that's all I got for you guys for 7.4, day 2. That's it for 7.4. This is our last day of this set of notes, and that's actually our last section in Chapter 7 that we're going to be covering. So the next thing we're going to be doing is just taking our Chapter 7 test. So we'll have a couple of days of review before we take the test. But as always, if you guys have any questions on this stuff, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.